In the video you're about to see, we are going to be using GPT to have a conversation to see if we can get it to come up with palindromes. And if that doesn't work, and spoiler alert, it doesn't work as well as it might be able to in the future, I don't know, or if we chose a better technique, can we get ChatGPT to at least write us a palindrome checker? Let's find out. Okay, so we are back. And I want to take the first 30 seconds to minute of this video to world build on this quote and to talk about what we want at the end of the video. This is being recorded at the beginning before we have a conversation with ChatGPT. We'll see how well it actually plays out, and then hopefully you'll have seen before this an introduction to what actually happened. Anyway, so this quote comes from an article about palindromes, and there's this guy who is just a palindrome master. I wish I remembered his first name, but you can see his last name is Duncan. And he basically gets hired to make palindromes. His whole career is built around making palindromes for people. He says in the article that his palindromes have made people cry, that he's come up with these extremely long palindromes. And palindromes are really interesting, especially if you know that if you studied computer science in college, you'll know that palindromes are a very common technique for teachers to want to introduce their students into programming, right? It's a pretty easy check in Java to say, like, do all the characters kind of meet in the middle and do they match each other on the way out? So for this quote, basically, he's saying that he starts in the middle of the palindrome. He thinks about vocabulary and kind of like which words to pull from, right? Because like you want it to sound like normal language, but you can't always use normal language if you're trying to keep the more rigid rule of the palindrome. So the middle isn't really important because that's when you build it out. But then it's really interesting because he's like, you don't want it to be obvious because that's like a seam, as it were, right? So you can see it kind of shaping up to the middle, and you could see the hard cut in the middle where the palindrome started, as opposed to like a regular sentence, which starts with the first word, for example. So what I want to do with GPT here is by the end of the video, I want to see how good ChatGPT is creating palindromes. And I also want to pseudocode a UI app to create palindromes from the middle, similar to kind of how Duncan does in this article. And really quickly, I want to draw attention to this ChatGPT MD comment. This is just a feature I just added. Funnily enough, from last video, I was in the middle of recording it. I was thinking like, oh, you know, ChatGPT needs some way to do comment blocks because I don't want to send everything here, but I couldn't really do triple backticks because that doesn't render like these ideas, right? Or excuse me, these Obsidian links. But if I take this same Obsidian link and I put it in here, it'll work, and you can highlight over it and you can use it just as normal. You can use everything else to, like, you know, bold and italic and stuff like that, right? Headings and such, right? So that is why I added this comment feature, because I think that sometimes you want to drop in and say, this is what I'm thinking right now, and you don't want it to be sent off to GPT. So anyway, we're just going to start off with the I'm a helpful assistant, the base prompt with 3.5 turbo, and we're going to say, first, let's say, we want it to come up with a list of palindromes following or starting from the middle. So come up with 3 palindromes using the word. Let's just choose a random word to see if it actually kind of gets it. So what's like a random word? Penguin. Penguin. I don't even know if you can do that. Well, let's find out how it does. Okay, let's see how it did. So this one's out. This one's not a palindrome. It ends on N. It starts with A. Penguin snuggle, gut, nuss, legs, snug as suns, help, I sung, nep. That looks close because this is sung, but then it's like that isn't that not right. Ava, can I see bees in a cave? Is this a palindrome? This is Ava, can I see bees in a cave. So this last one is a palindrome. It obviously didn't use penguin. One thing that'll be really interesting is let's see how GPT-4 does. So this was GPT 3.5. Let's see if GPT-4 fares any better. So let's run the same thing. So it came up with the same exact palindrome examples, but it added this note. This is not directly related to the word penguin, but it uses all the letters of the word, which is also not true, right? Because it doesn't have P or G or U for that matter. So definitely a pretty strong hallucination case. And I guess that makes sense, right? Because, you know, these are coming in as tokens. They're not actually coming in as characters. So one thing that we might want to try is that say like, okay, let's write out the letters one by one, starting from the middle. So let's try this again, starting from the middle in a numbered list format. So NIGUPENGUINUPIN. Nope. Nope. So none of these are palindromes as well. So again, this is all learning, right? We've learned that palindromes are hard, but maybe we can make a palindrome checker. So maybe let's say come up with a palindrome checker in JS that starts at the middle of the palindrome. Only write method stubs and JS docs. If you've seen my previous videos, you'll know that I like to write method stubs in one-line JS docs because this saves a ton of tokens. And I just think it's a better use of time in terms of reading for the user as well. So let's switch back to 3.5 because this is going to be writing code. So it's saying that doesn't exist. Sometimes the front matter takes a second to load because it's coming in as Obsidian's cache. Okay, so it didn't write it in a code block, but that's a relatively easy fix. We can just grab this and then say toggle code and then add 2 more here and add 2 more here. And then get rid of this one. Okay, so it says checks if a given string is a palindrome starting from the middle with the string as the input and returning a Boolean. So it's palindrome from middle. To do, implement this method. Find the middle index of a given string. If the length of the string is even, return an array with 2 indices representing both possible middle indices. The input string to find middle indices, and then the middle index or array with 2 middle indices if the length is even. Does that make sense? So if I have, yeah, that makes sense. If I have a 6 length character string, like, I don't know, what's a 6-letter word? Waters. Waters, right? These two are technically the middle, so you would have to check that these two match the T and the E. Okay, and then it says find middle index string, implement this method, and then we have an extra thing floating around here, so that's going to be relatively easy to get rid of. So that looks good. I think that, you know, let's say that, let's ask it to, which one is interesting? So this one, this find middle index isn't that interesting. So let's say that, like, let's do the, this one, this method. Let's expand on this. Expand on is palindrome from middle. So now it's actually doing this thing. So we had the find middle index thing, right? Okay, so now it just keeps going. I'm just gonna wait until it stops. Okay, So we say that the is palindrome from middle, looks for the middle indices, finds the middle index, and then for 0 up to the middle index, we start at the left, and then we start at the right of I or I plus 1, and then we say while this is this, return false. So like if the left index is greater than equal to 0 and the right index is less than the string length, so it's like you're out of the string, or I think you're in the middle, I guess. Yeah, because you're going out, right? If they're not equal, right? Because a palindrome has to be equal, then return false. And then we move one to the left and one to the right. So now let's try this again. So using the palindrome checker written above, I think I copied it in already. Yeah. Written above, run the function on 3 palindromes for penguin. So basically what we're testing here is we're seeing that A, can it run its own function that it just wrote? B, what kind of palindromes is it? Is it going to come up with better palindromes because now it has a checker? And then run through it step by step. So I don't know what's going to happen. Let's find out. So it's doing race car, defined, defied, in middle, which is going to be, yeah, it's printing a bunch. It actually ran out of tokens because I set my token limit to 512. So it stopped printing. But basically what we can see here is that we have a race car, which is indeed a palindrome, which we can see, right? Because it starts with E, C, C, A, R, R, which is interesting as a regular word. So we go to 2 to 4. It's basically saying that when we exit the while loop, that this is going to be true. For defied, we say that this is also true because this is same reason, or deified. And then for level, it would do the same thing, but we don't actually want that. So I want it to take away these examples, and then I want it to say like, okay, now create a new one using penguin. So let's just get, okay, using the above, whatever, create a new palindrome that has the word penguin. And this will be our final test. Let's see how it does. No. It is not a valid palindrome. A man, a plan, an eggplant, a penguin, Panama. So this is right. A-M, a man, P. So this should be an L. Okay. Let's just try this one more time, but with step by step trialing words. Okay, so let's see if it thinks about it. Okay, yeah. So this is S penguin sep SP, which is not a palindrome, but this says that it's true. I wonder if there's a way. Let's try GPT-4 one more time. Let's do the same test. And then we'll just call it a day here. So we're switching to GPT-4. And then taking it. So I'm going to highlight step by steps. So it like actually goes through and does 1, 2, 3, 4, 5, hopefully. And let's see what GPT-4 does. Start with the word penguin. Okay. Add characters to both inset watch in penguin. Sure. Yeah, but the problem is like that's not a word. It is a palindrome, but the word is meaningless. Okay. So you actually, it's not even a palindrome because it's UGN pension poo, which is not, because the U and the P and the U and the G don't work. So anyway, I guess that we learned something pretty interesting. We learned that GPT is really good at being able to write a method that can check if something is a palindrome, and just awful at actually writing palindromes, right? Which seemed pretty easy for us to check and verify, right? Using the same logic that the method is doing, right? We check this letter, then we check this letter. It's actually easier for a human to go. We have three different ways to look at it. We can read it backwards. We can start in the middle and kind of do the thing that GPT suggested, or we can start at the ends and move in. And GPT didn't seem to do any of those. But I think that this was an interesting experiment.